present the work with the title Performance of the qCON Index in Infants During Sevoflurane General Anesthesia.
So, thank you very much, Hugo, for the introduction. And this work was carried out by one of my PhD students, Juan Felipe Ortega, who unfortunately cannot attend the meeting today. And I've attended myself a number of times an ISAP meeting, and I remember one of the ISAPs I was sitting next to Donald Matthews, and he said, "Eric, in this room you will not find another room with more intelligent people than in here." So wow, I really have to put a lot of good work inside the abstract, and it's great educational value to be part of the ISAP. So I'm going to present the work we did, performance of the qCON index in infants during sevoflurane general anesthesia. And as we heard this morning, anesthesia, depth of anesthesia can be extremely important to outcome for infants, even apparently years after the anesthesia. For those of you who do not know the qCON index, it's a processed EEG index, which is implemented in the qCON monitor. And I also have to disclose that I am an employee in the company Quantum Medical, who is the manufacturer of the qCON monitor. So infants are known to present EEG differences when compared to other pediatric patients or to adult patients due to the maturity of the brain. So in this work, the ability of the qCON to reflect depth of anesthesia in infants is assessed, as well as the performance of the index using data from different EEG channels. So the index, as other processed EEG indices, is an index from 0 to 99, with 40 to 60 indicating adequate anesthesia range. So we analyze the EEG with fast Fourier transforms, we extract the spectral bands, and then we define the qCON index. Okay, excellent. So we were recording EEG from 19 channels and resamples in order to fit the algorithm of the qCON monitor and obtain the qCON values. And each recording was divided into 3 stages: awake, anesthesia, and recovery. The data were recorded at University of Vermont, University Center of Vermont Medical Center, and thank you to our collaborators at the University of Vermont who provided us with the data. As you can see, the advantage of having 19 channels is it gives us more space to analyze different types of EEG, whereas the processed EEG monitors would typically only have 1 or maximum 2 or perhaps 4 EEG channels. So it certainly is an advantage to have access to high channel EEG data. Sorry, I got one too much here. So the results from 10 infants from age from 46 to 540 days, that probably is an issue here in the data, that we have quite a long age range. I think there's a big difference between an EEG between an infant of 46 days and 540, but these are the data that we had available. But we could see that there's a significant difference between the values calculated awake versus anesthetized and recovered, both in frontal and temporal channels, the F3, F4, T5, and T6. And so we were able to make a prediction of loss of consciousness with the PK, the prediction probability number, of more than 0.85, achieved within all the channels except the O1. So in conclusion, the qCON index was able to distinguish between awake, anesthetized, and recovery, and showed good prediction of loss of consciousness. The best ones being frontal and temporal areas. So that suggests that it's possible to use a single channel for monitoring infants, but definitely more work and more data should be carried out before we can make a final conclusion, if we can make a claim that we can monitor down to very low age of neonatals in particular. Thank you for your attention.